I have to admit something. And it pains me to admit this, but... well... my pipes freeze. Look, it's my fault. Hey, don't stop it. Stop doing that.
Gotta get to the point, dude.
I'm getting to the point.
You know what? I'm cutting you off right there. You didn't bury the pipes deep enough in the ground when you built the place. That's the problem. You see, there's this depth in the ground called the frost line. The frost line is how deep the ground freezes in the winter. If the pipes are buried above it, they can freeze and block water flow. To fix it, you can dig them up and bury them deeper. That's a lot of work. Another option is heat trace, which is an electric cable that runs along the pipe to keep it warm. But then you still have to dig up the pipes, so it's just like, pfft. The way I've been dealing with this problem for years is to leave the faucet trickling, since moving water resists freezing. But that wastes water if you forget that it's on, and obviously it freezes if you don't turn it on because you forgot to check the forecast for the temperature for the night. I want to use the trickling option because it's the least physical work, and I'm tired. The issue is, it's very wasteful and inefficient due to my soft human brain just constantly forgetting to manage the water. Alright, so what are the consequences of mismanaging this water? Well, if I tear this on this weight scale and set it to milliliters and run the faucet for a minute, I can see exactly how much is coming out each minute, and then I can extrapolate and figure out how much is coming out if I forget and leave it on for 12 hours. 2, 1, 1 minute's worth of water at 105 milliliters. I did the math on that. It's about $9 a night. Whatever. That's not free, but it's also not the end of the world. What I really don't like is forgetting to turn the water on, waking up in the morning with the pipes frozen, and not being able to take a shower or flush the toilet. So what's the solution then? Well, I'll tell you. Well, gadgets. Well, gizmos. What I need is a cold, calculating machine.
That's what I wanted you to think with your soft human brain.
And my computer needs inputs, flow meters. It needs wires. Wires! It needs things to connect the wire to. This is how you solve plumbing problems. I'm gonna pick up all these wires now. I need to answer one simple question. What do I need to turn my water on and off based on the temperature outside, so that I can't forget to turn it on and don't have to remember to turn it off, and will make it so that I don't have to dig up any pipes, and also that I don't have to do anything that I don't at least think is kind of neat? The answer is quite simple, actually. I need all of these devices. Let me explain. Here we have a flow meter. Here we have a... oh, just 1 second. Let me just... So your pipes freeze sometimes in the winter, and it's too much work to dig them up and rebury them in the ground. Boy, do I have a straightforward, simple solution for you. Pop your little head under the sink and look what's under there with your eyes. You should have a hot line and a cold line. Doesn't matter which is which. All you need to do is disconnect both lines and insert a T-fitting, and then reconnect the lines. Then you need to insert some more flex lines over to a Y-fitting. The Y-fitting is going to go up to a device called a solenoid valve. Make sure your solenoid valve has an extra port for the water hammer arrestor you're also going to need. Let's pop a quick 12-volt proportional ball valve in the line so that we can vary the amount of flow we want according to the temperature outside. Of course, we're also going to need to know how much water flow there is, so go ahead and jam a flow meter in the line. Amazing work. And now we just close the loop with one final line, probably a dishwasher-style drain to give the trickling water somewhere to go. Wait a second. Don't we just want to turn the water on? Can't you do that with a solenoid valve and a temperature switch? You really want to add a 12-volt proportional ball valve and a flow meter? Please hold your questions until the end. Now all that's left is thinking sand. Dust off that old Raspberry Pi with that project you never finished from 3 years ago and download and install Home Assistant. Dig around in your junk drawer for an old ESP32 microcontroller. Most households have one. Then it's just a matter of getting a second ESP32 microcontroller ready for this little temperature sensor that we're going to put outside. Finally, we'll need a couple of 5 to 36 volt, 400 watt MOSFET trigger switches to help the ESP32 drive the 12 volt ball valve. Actually, you're right. Now that you mention it, we still need a 12 volt power supply to power some of these devices. Go ahead and get yourself one of these. It's just a simple way to take the 120 volts AC coming out of the wall and turn it into 12 volts DC for our little components here. All right, are you following? Are you writing all this down? You got this, right? you're saying this like it's a simple, lazy. Would you say a straightforward, simple solution?
Yeah, that's right. Why? What's wrong with it?
Just leaning more like more complicated. You know?
Oh, you think so, huh? That's funny, because we're just getting started, my friend.
Make sure you have a breadboard and a large assortment of wires, resistors, capacitors, and just a whole bunch of other shit you may or may not need. Go ahead and purchase a mid-range oscilloscope for like $800. Get a benchtop digital multimeter while you're at it, and a DC power supply too, because you have to, dude. You have to. You have to have these tools.
I have to have my tools!
Go to Home Depot with the expectation of finding all the plumbing fittings you need in the plumbing section and find out that not only do they not have what you need, but that they don't have what you need in like an evil way. Spend ages trying to find the right combination of this or that will make what they do happen to have in stock work, but it won't. Because it's just perfectly inadequate stock. You find just the right 3 things to make up for the one thing they didn't have, but that requires just one more other thing that you need 2 of, but then they only have 1 of that thing. I mean, it's actually amazing. It seems like designed to you. Purpose-built to trap you in a state of astonished confusion. Spin around in the store like a psycho and then just buy it on Amazon like you should have in the first place.
There's more, isn't there?
Software. The pipes need software. Get some software that updates firmware. And firmware that sends info back to software so the software can tell the firmware what to tell the devices to do so the software can tell you what the firmware is telling the devices to do within the software. We want data monitoring, automatic triggering, remote internet monitoring and control. An app. We need an app. Why? It's a pipe with a valve on it. Shut up. We need to get the temperature of the dirt right next to the pipes with that second ESP32. But look, no outlets, no power. We need lithium-ion batteries, solar panels to charge the lithium-ion batteries, circuit boards to regulate the charging of the lithium-ion batteries by the solar panels, a miniature hydroelectric generator? Okay, I'm sorry. I think we have everything we need. Okay, for clarity's sake, let's just really drive home what the idea is here. This is an artistic rendition of the inside, under the sink. We have all the devices, the solenoid valve, the ball valve, and the flow meter connected to the ESP32. Outside somewhere, we're going to put a temperature probe in the ground, connect it to the ESP32, and charge a battery with solar panels to keep this guy alive. When the ground gets cold enough, close to 0 degrees, this ESP32 is going to wirelessly communicate to this one and tell the solenoid valve to open and let the water through. Once it gets to the ball valve will open, and the water will trickle through the flow meter, giving feedback that everything is working properly, and escape through the drain. At some point, God willing, the ground will warm back up, the process will reverse, everything will close back up, and stop wasting water. Alright, so obviously I'm going intentionally overboard on this silly thing. I'm just going to take a step back, prune a couple of the sillier details, and then explain a couple of problems I came across while putting this stupid thing together, and we'll put it together and test it out. So the first thing I'm going to do is cancel the solenoid valve. And through the magic of canceling the solenoid valve, I can also cancel the water hammer arrestor. Yeah, so the original reason I wanted to have these things was to have a redundant way to turn the water off in case the ball valve didn't close. But I got to thinking about it and I decided I don't care. Actually, it might be worth a little tangent to explain what this is. Maybe somebody doesn't know why such a thing exists. In here, inside of this guy, there's a little electromagnet and a metal plunger. The metal plunger is connected to a spring, and the spring pushes down to provide a seal that blocks the water flow. If you apply a voltage, the electromagnet will pull the plunger up, and the water will be freed from its captivity. This one is actually directional, so it will only flow in that direction. When you remove the voltage, the valve closes really, really quickly. And because water doesn't compress, it just stops instantly. They call that water hammer, and it's bad. And so you put a water hammer arrestor at the inlet of the solenoid valve, and inside of this thing, there is another plunger and another spring. Maybe it's gas, maybe it's a metal spring, but somehow it absorbs the pressure of the water. It gives it a place to go, come to a complete stop slowly without smashing into the pipes. The reason I'm not so concerned about that with the ball valve is that it is a little device with a motor and a ball, and the motor turns the ball according to the voltage you give it. So this one is 0 to 10 volts. So if I give it 0 volts, it's all the way closed. If I give it 10 volts, it's all the way open. And everywhere in between is a percentage of how open you want, according to the voltage that you give. Like 5 volts is 50%, 7.5 volts is 75%. It also closes and opens really slowly. And because it closes and opens really slowly, the reduction in flow of the water changes much more gradually. And so water hammer just isn't as big of a concern here. Now, people have complained to me in the past that I've done seemingly random things with little to no explanation. So let me just take a second and explain that the flow meter is doing much more than just keeping track of the water. So if the microcontroller recognizes that it's cold enough outside, and it commands the ball valve to open, but there's no water flow, and it will send an alarm to my phone that something is wrong, and I can go deal with it before my pipes freeze. And obviously it can be used to calculate how much water I'm using as well, so. After getting the Raspberry Pi set up with Home Assistant and ESP Home added on, I set up the first ESP32 and started testing devices. Unfortunately, these trigger switches didn't work for me. You see, the ball valve requires 0 to 10 volts, but the ESP only outputs 0 to 3.3 volts. So the trigger switch lets me control a higher voltage with a lower voltage. In my case, I want to turn 12 volts on using 3.3 volts. So I connect 12 volts to one side from a separate source and trigger the output with my 3.3 volts from the ESP32. 3.3 volts in, 12 volts out. 0 volts in, 0 volts out. On, off, on, off. Now imagine I'm doing this like 1,000 times a second. I turn it on and turn it off 1,000 times every second. So I leave it on for 50% of the time, and I turn it off for 50% of the time. Doing that quickly makes it so that the device, or the output, more than likely doesn't have time to react to the change. What that means is you effectively get 50% of your voltage out, averaged over time. So if you're putting in 12 volts, you get 6 volts out. If you only left it on 25% of the time, then it would be 25% of the voltage, 3 volts. 75% of the time?
Anyone?
75% of the voltage, 9 volts. This modulating the width of the pulse is called pulse width modulation. And it did not work to control the ball valve. My hope was that I could use this technique to vary the percentage the ball valve was open, but it just didn't work. The electronics inside were too sensitive, and somehow it was reacting in plenty of time, and it was just opening all the way every time. And it was really frustrating, and I even tried a little filter circuit. Did not work either, and I didn't want to scrounge around doing a whole bunch of more parts, so I changed my method. DAC, digital to analog converter. Right, so the DAC is just a device on board the microcontroller that gives you a smooth output voltage, anywhere from 0 to 3.3. With a smooth output voltage, I can just use an operational amplifier, plug in 12 volts, and set the gain and control the output voltage with the DAC. Easy peasy, done, it works. Alright, enough of that. As I was testing and putting these devices together, I had to make a schematic to keep track of how to wire all this stuff together. It was like half wiring diagram, half schematic. I wouldn't have been able to do any simulations or anything. I ended up with the outdoor unit on the right side with the solar panel and the battery regulator. And on the left side, you can see the indoor unit with the ball valve driver and the water meter, and I added a leak detector sensor. I originally wanted to go through each and every one of these devices and explain how I got them to work and what I did and how the code worked and all kinds of stuff. But now it is obvious to me that that would be a 10-hour long video. This project ended up taking... I didn't set like a time or have any expectation for how long it took. I had no expectation for how long this was going to take, and it still took forever. Look at the beard growth from beginning of video to now. Like, I had to solder all the components to perf boards and design enclosures that were somewhat waterproof or water resistant a little bit. I 3D printed those. Then I had to get it all fit together, and look at this. Look what's happened. I got a mess here, but here's the leak detector. Leak detector's 2 metal probes. There's Home Assistant. Leak detector dry. Watch it. Watch the fingers. Watch the fingers. Touch. Wet. 0.87 volts. I'm gonna let go. Uh-oh. It's supposed to say dry now. Oh no! Oh man, it's been a lot of things. I learned a lot though. I even finally got around to learning how to heat seat these little threaded inserts for 3D prints, which is a deeply satisfying process. Alright, everything is mostly put together. There's the trusty ball valve and the flow meter. Here's the little leak detector. There's the indoor unit. Here's the cover. This case design, I was hoping if I made this little slot, see, once it's up in there like that, and then if water is dripping on top or starts spraying the front of it, my hope is because there's a little lip, a slot in there, and it goes inside, it'll be hard for the water to get up and down back onto the inside enough that it will get on the electronics if it's mounted on the wall like that. This guy, the outdoor unit, there's the battery inside, just underneath the circuit board there, and it'll be outside. Solar panels mounted on a wall somewhere, just like that. When I first built this place, I initially pulled this wire down under the sink in case I ever wanted to have a garbage disposal. So after all these years, I finally have a reason to install the outlet down here. I'm gonna go ahead and hang it off this switch on the load side of the GFCI. I only remember pulling Romex down here. I don't remember installing this box. It was amazingly lucky that when I cut this hole, it just happened to line up perfectly with the existing box. Like, what are the odds of that? Oh wow, it works. Now that the outlet is installed and all of the programming and everything is ready. Oh wait, hold on. All right, so all of the devices are ready to go. Got a red light here. This one's on. This one's on. It's plugged in. So we're just gonna do a test, and the automation's set up. All the code is running. All the devices seem to work. Finally, let's just do it, okay? I'm going to get some cold water. Ice, baby. Okay, clear this out now. All right. And here we have the drain with the dishwasher connector. Does it fit? Oh my God, I think it does. Oh, this plumbing smells like bad breath. This is horrible. First test. Please don't leak everywhere. I'm an idiot. I need this to be... That needs to be closed and this needs to be open. Okay. It's shooting water everywhere. Haha, it's leaking, but it works. Okay. I might not know how to do plumbing. I'm not a plumber. All right, I have to shore up these connections real quick. What kind of plumber are you if you don't have a bucket?
I hate plumbing. I hate plumbing.
Okay, so. All right, it's just leaking. For some reason, it stopped. It closed itself. I think the leak detector, the leak detector works. That's crazy. I wasn't even intending to test that. And then I continued to fix leaks and debug and get interrupted and confuse myself and reprogram and re-download for another hour or so before the real test began. All right, test number 1. Will the ball valve open if it's freezing? The probe is in the water. I quickly realized that the calibration I had done initially was done on a breadboard and that I needed to redo it since having soldered everything. I trust this thermometer with my food. I might as well trust it to do this. Calibrating, 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 calibrating. Now that it's calibrated, I should be able to read the temperature properly. Let's put it in some ice, see if it gets cold enough to turn the ball valve on. And now the classic confusion about why it's not working. There it goes. Replaced with confusion about why it is working. Okay. It's cold, it's trickling. All right, now when it's not cold out. Huh. It closes. I never have to forget to turn it on again. No more freezing pipes. All right, it's freezing out. It's gonna be cold as hell. Very, very cold. 47 degrees, 43. Let's get it right up on that ice. 39. There. Ah. That is so satisfying. That is such a long time coming. And it's warmed up outside. I don't want to waste any more water. There it is. These things are so badass. I'm so excited for the future of little home automation projects. All right. All we have to do now is install the stupid thing. It's not quite the ultra clean install I was envisioning, but, well, there it is. All right, and of course I just have to install the outdoor unit now. I'm gonna put it right here. It's as good a place as any, I think. Get that direct burial temperature measurement in the ground. I did screw up, put the hole on the wrong side, so I'm gonna have to redo it anyway. But I think this will work for now. Looks pretty amateur, but yeah, probably gonna work just fine. If you made it this far in the video, tell me what was stupid. What did you like? What did you not like? How can I know if you don't tell me?